Hello everyone, welcome to Learn Overflow. In this video, we'll discuss another LeetCode problem. That is a check if a sentence is pangram. So we need to check whether a sentence is pangram or not. This is an easy level problem, and we'll understand step by step how we can solve this question. Also, before moving on, if you haven't subscribed to this channel, make sure to subscribe to Learn Overflow for regular LeetCode videos like this. The question first discusses what the pangram is. The pangram is basically a sentence of where every letter of the English alphabet appears at least once. Fine. So it's like it's compulsory that every letter should appear at least once. So that's what necessary. Now, if you just look carefully, this is a sentence given to us. Fine. This is the one, that the quick brown fox jumps over the ledge dog. So this was a sentence, and this sentence you will find it true because you'll find every letter of our English alphabet from A till Z. Everyone is there at least once. Like there's one time you will find it here. Fine. So the sentence contains at least one of the every letters. So the other case is like LeetCode. If they are given, it's a false because it's not to that point. Okay, it's not there whether everyone is there or not. Fine. So our main target is to find out if there's like every letter is there at least once, right? The question further says like we are given the string sentence containing only in lowercase English letters. So everything is lowercase. Return true if the sentence is a pangram or otherwise false. So it's a pretty simple question. So you need to check for that. Now, what should be your approach to this question? The first approach that must come to your mind as a array-based approach. What is that? You create an array of size 26, fine. And initially, the array default values are 0. Make it an int type array, and then for each of the characters, users do like for the character minus this a. Okay, so whenever you do something like this, okay, a. So if you do something like this returns your index or a number. So how it works? Say so the character of that sentence, what you find out is like b, fine. So what is happens? So b minus a. So this happens, and with that case, you will return it. So B is 98. Okay, B is 98, and in terms of that, A is 97. So you will find one as the answer. Fine. So that's what you will find out of it. Now, this is the first thing that will work, and that's one being the index of that. Make it a 26 letter array, and then you find the index out of it, and then put the index and just keep adding to the particular index, like incrementing the index. So at the end, once the sentence is over, you just traverse through that whole array and find out if any character remains zero, then it's not a pangram. Else, if the whole array gets over and all characters have some value, at least one value, so it's a pangram. So that's a basic idea you can do. Now to improve that, what you can do, you can actually shift this, like not use an array, rather use a map or set. In that, you just like keep on adding all the values in the set. Fine. So at the end, you just check whether the set size is 26 or not. Fine. So that's pretty much easy. But like set size is simply return as that. So these are like two ways that you can do. But there is another way which you should learn. Okay, it's like these are the ways you can come up easily. But maybe in an interview, the interview is not looking for these are the ways. Interview may ask you, can you improve it further? So what you can do is like use a bitwise approach. Okay, like in bits use this, and that approach will be helpful for us. So how we'll go ahead with that? The first thing we'll do is like this particular concept that I explained it to here, that this will be helpful. Okay, this we'll use that. So what we'll actually do, we keep a like a in type okay, in type scene variable or a variable that will help us to know whether we have seen a particular number or not. Fine. Fine, that will do. And then we will continuously left shift our value. So whatever this value we are coming up, like c minus a, this particular for each character we're doing this. So whatever this value we are coming up, we'll do a left shift of how many times. We'll do something like one left shift, this say this value being c1 or something like the ci. So we'll continuously do a left shift of this. So what will happen, say there's b, like the character is b, so it comes up 1, so the value will ultimately come up to something like it will be 1 0. Okay, so that's the value we'll be looking for, because that's b, like if it is b, so the end value will be something like 1 0. Fine, because that's one shift being moved. If it was a, so it was being 0 1. Okay, for c it will be 100 1 0 0. So you can see that like the characters are like not at the same place. So at the end, like at the end of the traversing the whole sentence, you should have 26 ones. Okay, you should have 26 ones, 26 times. Fine, that should be there in your like after doing that, after doing each of the left shift. Fine. Now, what exactly we are doing at the last? We will simply do. We'll simply check if we do a one left shift 26. Fine, we'll do a one left shift 26, and we'll check whether this one left shift 26 is equal to this particular value that will come up. Okay, this particular value that will come up, it should be 26 once. So if this particular value plus one, okay, what will happen? Everything is one, and when you plus one to it, it will be like 27th bit will be one, and then 26 zeros will be there. Okay, so that will be come up. So we'll check one left shift 26 will again be that exact thing. So 27th bit will be one, and there is like 26 zeros. Why is it so? Remember when you had B, that is one over here. Okay, when you left shift one left shift this B, that comes up to be something like this. That is second bit is one, and the first there are like one zeros are there. Fine, that's what it is. So how whatever the left shift is, like how many bits were left shifted, it basically means there will be that much zeros at the end. Fine. So this is the idea. So it should be like 26 zeros at the end, and also 26 bit characters plus one, like all the 26 ones. Add a one, like if you add a one to it, it should result in again the same thing. So that's the pretty much check we can do. So what's the improvement we come up over here? Fine. The firstly, when we are using arrays as a example, in that case we didn't have like we have to traverse the whole sentence, and then we have to traverse again 26 letters array to find out if there's a mistake or not. So it's like going into like order of n, n being the length of the array, twice or thrice, like at least twice you are going. But like the overall order is not changing, but the overall time it will take, it will change, because first you are traversing through the sentence for each of the character in the sentence, and then you are traversing through this whole array. Fine. So that's the what you need to do there. But when you improve to set, you will find out like you keep adding them all again. Like you traverse to the whole sentence, that order of n is there, and added to that you need to find the size of the, like calculate the size of the set. Okay, so set size, you can use directly the function, but that function also takes an order, right? It calculates that internally. So that takes time. But what is the improvement you come up over here? Here, first of all, that traversing to the whole sentence character by character is same for all approaches, but over here you are not using much of the additional space. Additional space as in you are just doing additional space to store this one. Okay, that 26 character letters or this scene variable is that just an int type variable. Now using this, you can simply find the solution to this. But remember, there is a small catch in this question. The small catch is here you are looking for like 27 bit is one at last, and then 26 zeros are there. That should be the ultimate result we are looking for returning true, right? But how is this holds true? This holds true simply because the int type variable, whenever we take it, it is a 32 bit. Fine. So it has 32 bits. So that's why we can easily go ahead and use it there. But say in other program, they gave you something, but there isn't like 26 characters of the English alphabet only. That there are more characters there. They have added some characters. So if that is the case, you need to check whether it comes up in the 32 bit or not. If not, we have to go with the set. Fine. Now this holds true because of that, because we have only 26 characters, and in that case, it is less than or 32 bits, so we can easily use this bitwise operation to do that. Now, quickly, let me quickly go ahead and write this code and then show it to you how fast or slow it works with our respective file. Let's quickly go ahead with that. There is it's come up with a 1 millisecond solution. Obviously, it's a 0 millisecond solution, but at times LeetCode is there with this madness. It doesn't matter. Let's look at the solution again, understand it again what we did. So first of all, as I said, we took a integer variable c, and this variable we are like doing a character by character. We are traversing character by character in our sentence. Okay, and then we are doing this operation like we do in c1 is equal to c minus a. So as I say, whenever you have this c minus a, is basically finding out the index of the value. Okay, so let's understand this sentence one by one. So we have this take a case like we have this variable abc that's only given to us. Fine. Now what's happening exactly is like we've come up with a first. So c minus a is like 0. Fine. So that c1 initially becomes 0, and then we're doing scene is 0 itself. So scene is 0. So scene, or we're doing OR operation of one left shift 0. So once left shift 0 is, so this 0 becomes one left shift 0 is like 1 itself. Okay, that is like 0 0 0 0 0 then 1. Fine, that's happening. And then we are doing an OR operation of the scene. What is the scene? Scene was initially 0 0 0, like all characters are 0, right? So we're doing an OR operation. So after OR operation, it simply becomes 0 0 1, right? That's what it becomes. Now Further, what will happen? We'll come up with the next character. Next character is B. Fine. Next character is B. So B is like B minus that A. What it happens? It simply becomes 1. Okay. Why? Because 98 minus 97. That they are ASCII values. Okay. So 98 minus 97, you will find out to be 1. Then you need to do a left shift 1. So 1 left shift 1 is like 1 0. Fine. So that's 1 left shift 1. So I'm setting an additional 0 before it because like keeping it 3 bits. And then we are doing an OR operation with scene. So what is scene previously? 001. So what if we just do an OR operation over here? See, if we do an OR operation over here, it simply becomes 011, right? That means that simply means we just found this characters, or we just found these bits, or the characters are there. Then what we come up? We come up with C. C over C will find the character C is there. Fine. So then the C minus A will give us 2. So 2 means 1 0 0. Why? We are left shifting 1 2 bits. So that's 1 0 0. That is 2 zeros at the end. How many bits we are left shifting is like adding to that much 0 at the end. Fine. Then we are doing OR operation with the scene. So scene was 0 1 1, and we are doing OR operation of 1 0 0. Fine. We're doing this. So what comes up as a result? So it comes up like 1 1 1. Fine. And further, like you may think like what comes up next. So further, if there's another one, like another A will be like 001, right? So that will be there. So we'll do like after 2 we'll do a OR operation. So it's like 0 0 1. So what is the OR operation of 1 and 1? Like true and true is true itself, right? So that's what it will result in 1 itself. So once you have found this character, it will remain 1 continuously. There's no problem with that. But if any character, so at the end it will be, at least it will go ahead with 26 character. We need to find the or every letter, right? So it will go up to 26 characters. So at the end we should be having a number that is 26 times 1. Fine. That's 26 times 1 should be there. Fine. That should be there over here. Now, what's going on next is like we just found out, there's 26 times 1. Now, what if we got this 26 times 1 in our scene variable? Fine. In our scene variable, if we add 1 to it, see, we didn't add it here. We actually subtracted it on the other side. It's just same. You just take it, make it add over here. So what is it? What if we add 1 at the end? So if we just do some binary addition, then you'll find it will become like 27 bit as 1, and then 26 zeros will end up having. Fine. So this is end up happening. And then again, 1 left shift 26 is the same thing. If this happens exactly, fine, if this is exactly what we come up to as an answer, then it is something we will say, okay, we found our answer. Like this is a true. But in case there's any bit which is not 1, say there's a bit over here that is 0, then what will happen? Or subtracting 1 or addition, like adding 1 to this won't result in like all bits being like this. Fine, it will just add up 1 over there. Like after this 0, all the bits will be 0, and before this, all the bits will be 1. And this bit will also change 1 after adding 1. So this will happen, right? And thus we can say whether it's an particular value like a panagram or not. So I hope this is understandable how you can go ahead with the solution over here. So thank you all for watching this video. If you have any doubts with this, make sure to comment them down. I'll be happy to help you out in the comments as well. And also like this video and subscribe to the channel for regular LeetCode videos like this. Thank you all for watching this video.